Welcome back to Learning Analytics Tools course. In this week, we will just overview what we learned in this whole semester. There won't be any new topics taught in this class, but we will revisit what we discussed in an abstract view. So, in this course so far we talked about data collection, that is what data to collect and from which environment. Then we talked about how to represent the data, that is very key and important aspects. Because we can collect data in a different learning environment from the different resources, but representing data is very key. I suggested a simple method, that is I suggested the method that is you always have a timestamp, timestamp and user ID. If you allow the students to do multiple sessions, you have a classroom environment where students have to do it 2-3 times, come to the class, or they have to interact with the system for multiple times, or in online they have to interact for multiple times, collect the session ID and the action they are doing. What is the action? Are they doing reading, are they doing some uploading a task or assignment, something like that. And from the actions you also should collect the contextual data. The contextual data is where this action is taking place, where and what are they doing, like if they are reading some page, what page they are reading and why they are doing it. They are simulator, they are interacting with you, they are uploading assignment, they are uploading for what, for performance or some other indicator why. Also, if they are answering some questions in a quiz or in online assignments, please think about what is the option they select and what was the correct option. So, if the action is answering to a question in MCQ, so you need both correct option, what option is selected. So, think about all these things, current option, what option is selected. So, this is the action and the contextual information. So, how do we come up with the actions in 3 different environments? That is a very key important point, right. So, I might have in interacting with a technology enhanced learning environment, I might have interaction like navigating from one window to other window, clicking some buttons. Every clicks I am capturing, right. That is why I suggested you capture all the clicks. But can I consider everything as action? Not necessarily, because if you consider everything as action, there will be too many features to come up. So, if you are talking about action, think of the major actions they do. It is only the major actions. For example, in a Moodle or in a MOOC systems or in a technology enhanced learning environment, what is the major actions they do? You might consider login, login as the logging into a system or system response. That is maybe start of the action, that is not necessarily important for us when you do the analysis in a sequential manner, but you consider login is important just to know when it is started. The login is associated with the session ID, that also gives you, are they session is continued or they logged in multiple times. And by login ID you can construct features like how many times the login happened in a week, in a day or within hours, and how long they spent, average time they spent on each login time. After logging in, what are the main actions they do in the environment? For example, if you use some LMS, they might be reading something, watching videos, right. So, reading, watching videos or answering questions. So, you can talk it as a quiz, you can mark it as a quiz, answering questions, the quiz, or they might be in the discussion forum, discussions. What else? Is there anything, something specific to the system? Just mark it. Some of systems we saw they are interacting with the simulator, some systems they are drag and dropping something. So, if you have any specific items, mark that as actions. Now, for each action in a read, if the student is reading, are they reading which page or which PDF or what are the content they are reading. If you chunk the content into smaller concepts, it is easy to track that. Then if they are watching a video, what are they watching the video? If you want a minute data, talk about are they watching in a single 1x speed or 1.5x speed, And we most of the people know, we do mostly when you watch the online lectures, if it is very slow, we watch in 1.5x speed, that works well. So, watching speed, all this seeking the video from one place to place, you can add all this information as a contextual information, this I mean as a contextual information. These are the major actions listed in the thing, then contextual information. The first step when you do the analysis is that you plot these actions frequency, number of times occurred for each student in average, the time they spent on each of these actions. And if there is some interesting aspect happens, go look into the contextual information, why this student is looking at it. A typical example is, for example, you have 100 students, okay. You saw 50 students based on a pre-test and post-test score, they are low performers, and 50 students based on pre-test score, they are high performers. Or maybe say instead of 50, let me put it out, no, this is 40, there are some 35, and there are in between, some students who were not neither low nor neither high, but in between. So, we do not want to classify everyone just below 50, like 49 is a low or 51 is high, that makes no sense. So, we can give a median value or some gap, maybe we can consider that as a medium performance, or we can keep it as a buffer, saying that I want to clear students who are really got less than 30, students who got above 70 is a low and high, you can make your own bifurcation, right. So, that is it. Now, you have this data. First step you do is, after collecting these features, the features you were talking about, login, read, watching, plot the graph, and find out is there any difference like in the frequency, in the average time they spent. If there is a difference, well and good, go and talk about it, why the difference, whether that difference can impact the student's performance, that is hypothesis, test it out with the data, correlation or do prediction, that is good. But you see that for both students, all of them are reading time is same, watching time is also same, kind of same, there is no significant difference, you can run a significant test on this data. Then you might want to go further. If both low end students are reading for 5 minutes on an average, how some students are able to get good score comes to not able to good score, maybe it lies in the what are they reading and how are they reading. Now, we go look into the contextual information and see is there any difference in the context comes out. That is how we do the analysis. So, I was trying to explain this in a week 2. So, you might have had the idea of what is actions, what are the context, but I want to give you the picture why it is happening in the learning analytics. Next is we do analysis. So, we do analysis, I was explaining that. Then you do reporting. So, since there are a lot of data and you need a lot of graphs, do you want to report everything to when you publish it, or you want to report everything to a stakeholder? So, depending on what are you reporting and whom you are reporting, you have to make a graph and make a plot or make inference out of it and report it. So, make sure that you know what are reporting and who are reporting and what is their interest also, what you want to tell them, like you do not want to tell all the story to the everyone in the public. So, you might be interesting saying that, hey, we know all these other factors are already established in literature, we also found it same, but there is something new we found it which is not exist anywhere in literature, we want to talk about that, let us talk about that, something new. So, that is a gap you have to identify and report it. Okay. Then after reporting, the whole idea is to to understand the learning process and improve the teaching learning strategy. So, this is kind of what is learning analytics definition I talked about in a week 1 lecture. If you remember what is learning analytics is to collect data, measure, collect, report, analysis in the context of students working on it, and in order to improve the students learning. The primary goal is to improve students learning, it is not nothing about you create a model, you are able to predict the students performance. No, it is about how to use that knowledge to improve your teaching learning strategies so the students learn better. Okay. So, we talked about different learning environments like face to face, online systems, and also LMS kind of things. Online systems includes LMS and tele both. So, in a face to face, most of the data collection is by self reporting. This is a key, actually very important. Most of the data is collected by self reporting or human observation. They are the only things you can do. Okay. Self reporting is that you might run a survey, ask student, hey, what are you feeling about, or how many students are engaged in the class, or you ask them some kind of questions, they answer something, and based on that you can identify whether they understood or not. And self reporting can be form of it can be in the online also, but you can be check a small piece of paper passed on the classroom and they will answer some set of questions. Or the second way of collecting data is human observation. You are a teacher, you are instructor, you are in the class and you are collecting students performance, students engagement, students activities, or number of times the students interacted with the peer, all these things you are collecting. Human observation is one of the valid or well accepted observation. The only key point is the researcher should not get biased to labeling each and every action of the students, the participants. So, in order to avoid bias, please create a inter-rater or inter-observable reliability. So, it is based on is it observer or rater, it is called inter-observable reliability. So, we use Kogan's kappa. We talked about Kogan's kappa also in our earlier weeks. So, we mentioned the kappa is used to compare two performance of two systems or to to measure the agreement between two observers. So, look at what is inter-rater reliability, how to use Kogan's kappa if you are doing human observation. This is a very key part. The reason is you should not get biased to labeling the particular variable you are recording. Say for example, in the classroom I want to understand the students engagement, and you might be the observer standing in the classroom. Say there are five observers observing a class of 50. Each observer is observing 50 students, they are observing the round robin method. So, that is every 2 minutes I will observe student 1, next 2 minutes I will observe student 2, like at the end of 20th minute you observe all the 10 students and you come back to the again 22nd minute you will be observing the same student again, and you are marking in a note saying that student 1 from time 10 to 10:02 is engaged and he interacted with the peer for 5 minutes, all the coding. So, you have to first come up with the coding mechanism, what all things you have to code. There are a lot of this is called qualitative research. There are a lot of resource available in such articles. Go and look at the coding existing, you might find a new coding, find it out. Once you have a coding, you record students engagement, all this thing, and how do you compare whether you are doing it correctly, you are not biased. So, what you do, you compare your coding with your peers, other person's coding. So, in that when you compare inter-observable reliability, you both observer, both 2 or 3 or more observers has to observe the same student for a certain period of time. So, usually when we start this never happens, this kappa is not may not be good, kappa may not be good, may not be really great. Okay. So, what we do so kappa might be low. At the beginning. Okay. So, what you do is first you will have a set of rubrics to mark this when a student moves and talks is kind of engagement, you have your own rubrics coding mechanism. You discuss with your peer and both understand the coding mechanism, both are observing. After observation you do the kappa calculation. If the kappa is low, if the kappa is less than if the kappa is if the kappa is less than say 0.8, discuss with your peer who is other observer and talk where the mistakes made and why he thought that is a particular not engagement and you thought it is engagement, why you thought it is not engagement, why the particular other observer thought it is engaged. Discuss and resolve the conflicts, redo the assignment, again observation of a new student or same student for a new set of period of time. Okay. Then you check again the kappa score, make sure the kappa score is more than 0.8 or more than 0.8. That is a very key aspect when you are doing the human observation. Okay, that is a very key. Sometimes it is not that you will be observing the students in a real real live environment. You might be recorded the students facial expressions, students actions in the class, and you will be looking at the video and recording it because you want more data. If you want to observe the data in a real classroom, you may not be able to observe all the 50 students data, or you do not have too many observers to observe the data. So, you do not have real amount of data. So, what you might do is you might keep 2 or 3 cameras, record the students actions, and you might look at the student 1 in the camera and make down their list down their engagement. In those scenarios again talk to your inter-observer, both watch the same amount of time, say 5 minutes or 10 minutes of video, and mark down all the rubrics, make sure the kappa is greater than 0.8. If not, again redo the assignment on a new student or a new time frame, not the same time frame which you already observed. So, make sure you make the kappa is more than 0.8. So, even observation can happen in a real time also in the video. That is the thing I want to discuss here. The second one is online systems, self-reporting. It is not just self-reporting of surveys, also the students is answering the questions, performance, all these things can also consider. Other thing is clickstream data, human observation data. In general, not in LA, but in an ITS, intelligent tutoring system kind of environment, what we consider is simple thing. There are something called a profile. This is kind of a static information. Static in the sense it's a profile of a student, like age, gender, the year of the study, the prior knowledge, maybe if you are collecting the parents information, all this thing is kind of profile information when they come to systems, kind of a static. And clickstream data is other data, you observe all the interactions. And then you might the performance data is another data. So, profile, performance, clickstream data, like that is the data we compare. By using the clickstream data and the performance, by combining these two, you might be coming up with some dynamic data. What I mean dynamic data, you might be measuring the skill, or you might be measuring the engagement, something you might be measuring something for your research. That data is dynamic. Why I say dynamic? At the beginning you might start with median value or middle value, then based on the student's clickstream and performance you will change it whether delta increases or decreases. So, a student is performing very well and is interacting with all the artifacts in the system, you might increase the engagement more and more. They are not interacting with all the system, they are just simply watching a video, they are not doing any performance, you might reduce some other skills can be reduced. So, this is changed based on the student's performance and the dynamic. So, in general the data is that the 4 data only. By using this dynamic data, what you actually provide a new feedback, a new content, it is part of intelligent tutoring systems. So, that is the whole idea. So, that is the whole idea of clickstream data. Even in online systems you do the human observation, that is why I said that if you might capture the videos or something and you might sit down and record the facial expressions and do it. For example, in online environment you might be capturing students facial expressions or data from eye trackers or something else. If you have facial expressions data, you may not be able to code it directly. You can ask the students to self-report about their own emotions watching their own videos, or you can observers can observe the students facial expressions and code their emotions, affective states. So, in any case make sure that you do the cogents kappa and the kappa score is more than 0.8. There should be no bias in human observation. If you are not doing that, that people do not consider that data is valid, that is very important. So, all this data collection, any environment, any data you collect, please get the participants consent, and if you are getting a participant consent, please make sure with whom you can share the data, who has access to data, in the future what you will do, what are their rights, and think about all these things when you do the participants consent data. Okay. So, what we talked about is in the environments we might collect data from different instruments like surveys and the clickstream data, quizzes, the test performance, all these things we talked about. And these are all raw data, right, and from this we get a raw data like a response to questions or the clicks, they speak some utterances or the facial expressions, it's all there raw data. So now think for a minute, how do you extract features from this raw data and why we are doing that, that is very very key important. I can collect all the data, facial expressions, they are talking, the utterances and the clicks, every clicks, responses, performance. Why you are doing that and why, how do you extract features from this log data? Please pause for a minute and write down your answer. After writing it down, resume to continue. So the feature extraction, why we are doing it depends on why we are doing it, that is why you have to go and predict something and you have to extract the features to identify the student, compare the students with the other students, to compare with the baseline performance, everything. And what features to extract, it depends on the research goal, okay, that is why I mentioned in the first slide, and the actions. You want to go context to information level or simply the actions. So you come up with their own number of features, whether it is simply the major actions level or actions combined with the context to information. And this is where the domain knowledge is important. Not everyone will be extracting a good feature, the one who is working on the domain, say education domain, will be able to extract a good feature. If you are creating your own system and the students interaction with the system means something, so then you might be able to tell from the experience, the expert's knowledge you have in that particular system, the particular domain, you might say students clicking these 3 buttons or reading for 5 minutes and doing quiz might be look like the student is reading this or something. How do we know that? It's like it's your expertise, and if I talk to teacher in a classroom environment, if a student is coming for only 40% of time for attendance and is not submitting 3 assignments at all, will he pass the exam? The teacher will say, yeah, I will not pass the exam because I know it, because based on experience you can tell that. So this is called, I call this a domain knowledge. That domain knowledge is the expertise knowledge you might possess in this domain. The same data collection machine learning method can be applied if you know the domain of mechanical engineering, you might apply in that mechanical engineering problem, or if you know some other domain you can apply that. So my focus with your expertise in the learning environments in the learning, please use that knowledge for the creating features. And this is important, the reason is the domain knowledge will be built up based on how many years you are working on it, how many features, how many systems you created, how many features you are extracting. The one way to start is read the research papers to understand how they extract features, what are the features extracted in a similar environment. Look at those features, list down all the features, then you might be able to come up with your own set of features, or combine some features to create your own features. And frequency and time is important. I said that if there is a major actions, simply create a feature as a frequency of that action over a certain period, say over last 1 hour, last few hours, last 2 days, last 3 days, last 5 days, over 1 session, over last 5 sessions, frequency of any major action. For example, if the major action is reading, what I do is number of times read, okay, number of read in 1 session. I am not talking about what are they reading, which page they are reading, that is if needed you go further, but I am just saying if you are reading, just go about how many times they are reading. Same so same number of read in last 5 sessions, or same in 40 minutes. So you can extract multiple features from from one major action. So why do we expect multiple features? You can extract multiple features and find out which features are redundant by do a correlation analysis or correlation with the a dependent variable, or feature extraction methods will help you to do that. So that is a feature you might have something. How do you might say no that does not make looking at the read session for last 5 years, you might say that is perfectly correct if you have a particular domain knowledge. You might say no this particular scenario I do not think last 5 sessions of reading will not really helpful, you can remove it. That is why I say it is a domain knowledge is applicable. So, for same read action I will create multiple features based on the time. Average read time in one session, it is that, and you can talk about average read in last 20 minutes or average read in last 5 sessions, or you can be specific that average read before taking quiz, something like that. So, here I am combining 2 actions. So, you can come up with a lot of features, that is why I am saying that go and look at the papers already which is talked about this, and also the domain knowledge will help you to come up with it. You can say that if a student is reading more than 3 minutes before taking the quiz, then there might be you might be doing better, or if the student is reading many times like spending 5 minutes and you did some other actions, then quiz this may not be good. So, you might come up with your own hypothesis. To test it, you extract these features from the raw data. So, there are 2 things, frequency and time, these are very basics, and you can all start with that. How do you improve this set of features, how to come up with the new features and combining multiple major actions, or you can combine the major plus contextual information, it is all come up with your domain knowledge. Okay, let us start from here, that is what I say. So, and what we did also, we talked about basics in machine learning algorithms. We talked about pattern mining, process mining, and clustering techniques, performance metrics, some of the regression logistic linears, naive Bayes, decision tree. We talked about all these things in this course. So, revisit them, what is pattern mining and process mining. Most of you might know the clustering techniques and regression. Process mining and pattern mining might be new to many of you. Check it again, it is very interesting, and check for associate mining also for the pattern mining. And importantly, this performance metric might be something new. The reason is not many people cared about what is a metric, what to look for, that is very important, and why this metric is needed is also I wanted to inform you guys, so that you know how to compare 2 things. Then how these algorithms are trained, I never talked about it. In a linear regression I said that simply linear regression I said that there is a magic app, there are a lot of dots, there is a one line, and there is another line. I said which line to pick, I told which line to pick. The which line to pick is easy, just because we know that. So, from the each dot you have to find out the gap. Sorry, this is the one loss function of this, and similarly this loss function for this is a different, and you take the one which is. But how do I change, whether dash I change, if I find this loss function, so should I change it to an upper direction, should I move it down? I never talked about how it is trained. There is a reason for that, and I also never talked about hyperparameters in each algorithm, because I first talk about training I should be involving hyperparameters. At the beginning of the course, also in the introduction, I clearly mentioned this course is for someone who is new to the machine learning and who do not require any mathematics or anything. So, I completely avoided the calculus in this course. So, in order to avoid calculus, I did not do the talk about how it is trained and what are the hyperparameters in each algorithm. But I request all of you to go, and if you are interested to more about that, go and watch videos by Professor Andrew Ng in each of this each of these recordings, and learn more about it, or lot of very good resources are available in internet. If you are really interested about machine learning, there are very good books available in machine learning also. Okay. The aim or focus of this course is not that, it is not to teach every algorithm with training and training and hyperparameters, because this course is not for only the one who is already well trained in the mathematics or will know the programming or something like that. This is for everyone. So, I just kept that part very low. If you are much motivated because of, hey, this is interesting, I want to know more, please read further. Okay. So, also in this course we talked about multiple tools. ISAT, we had a video, I hope you would have done the assignment on ISAT. Use it, the ISAT tool is available, just use it and check the score. If it is useful, use it, and you can contact the developer and he will be happy, and you can do that. Also we have given small scripts to run a sequential pattern mining. It is not it is not a tool as ISAT or the other big tool, but we wrote a small script to extract the sequential pattern mining. If you find some other tools available online, please go and use it, there is no no harm. It might call as associate mining or something like that. So, understand what is pattern mining, it checks the frequent patterns in a fine grained level, and what is a process mining. A process mining observes old process. So, process mining we introduced ProM software that is available for free for academic usage, also for commercial there is one software for free. So, use that software too. Veka is completely free for everyone, use it. Orange is free for academic. So, use these tools, do not stop only with these tools. If you are interested, go to Tableau, go to Rapid Miner, explore more tools. I will talk about that in detail, how you can expand your the next steps. But these 5 tools we covered, and make sure you learn everything well, and if the videos are not enough, go and check YouTube videos for Process Miner, Veka on Orange. ISAT, that is simple, very simple to do. We gave a sample data, just upload it, you will see everything, we just have to click buttons, it is very simple. SPM, it's not it may not be the complete tool, you have to run a script. If you are interested, search other softwares which talks about associate mining. We do not find any good software for associate mining in an educational setup that can be shared freely with everyone. That is why we have to write our own scripts. Okay. Hope you guys enjoyed that interacting with the tools, because this course is about tools, and this main focus is that you get to know some tools and apply on some data. So, now I want to ask something different, that is, what is the difference between 20th century and 21st century? When I say 20th century, imagine the time before 2000, or you can go up to 2003 or 4. What is the difference between 20th century teachers learners versus 21st century teachers learners? Think about it, write down your answers. After writing it down, please assume to continue. In 20th century, we see teachers as a source of knowledge. I did not have access to most of the books, only the library have limited books. The teacher has all access to books, the library books, and he might have a notes from somewhere, he might have read a lot of books, and in the library also he has a special access, you have all the access to books. And the teacher teaches everything with examples. There is a textbook, he covers each and every syllabus, and he explains the problem, and he goes off and asks us to solve the exercise solutions and problems. If you have doubts, the teachers might teach. And we see teacher as the guru, like he is a elixir of knowledge, and he has everything, and he is the one person to go after for everything, to ask for this, and he is always there to answer my questions, and he guides, in fact not just teaching, the good teacher guides beyond your subject, hey, what to do, how to do, and a lot of discussions, a lot of things happened. This is 21st century teacher. Most of you might be, if you are a teacher, if you are a teacher and you are born in the 1980s, you might have seen the 20th century teachers. But if you are a teacher now, you are continuing that, you are not a 20th century teacher, you are 21st century teacher. What is 21st century teacher? You are not a source of knowledge anymore, okay. Whatever data you can access, whatever resource you have, the students have more than that. Students have access to lot of more data and lot of more resources. You are not a source of knowledge. Do not expect that you have to teach everything and you have to be there and you know everything, that is all gone. It Student knows more than you in a particular subject, and not just students, lot of industry experts, and everybody writes their own blog. It all changed after Web 2.0 and the videos coming in YouTube or other video video serving platforms. So you are a motivator to students, like which course to do, and the students for resources guides them, hey, look at this particular resources for this particular topic. But that does not works much, they are the rating agencies. You go to Quora, you check out which resource is good, you read about it, but you pulling together saying that do this particular task, maybe you are guiding them what to do next if they have any issues, but you are not you are not the only person who's source of knowledge. That is what I was trying to say. So, you be a motivator and do that. So, I picked up that I am not a 20th century teacher, I was a 20th century student. I was asking my teacher for everything. I go to library, only the library has 4 books, I read notes, I read it. But now I am a 21st century teacher. I did not teach everything about all these videos. What I try to do is motivate you on, make an interest on, hey, this is linear regression, this is logistic regression, this is naive Bayes, this can be applied here, this is decision tree. I did not talk about anything about decision tree in detail. This is a decision tree, how to do it, there are 2 important parameters. With that knowledge, what is entropy and information gain in decision tree, you can go to any resource, now you can pick it up easily. So, now you know what is these 2, and you can watch a new video or read a paper or read a book, you might get more information and more interest, all depends on your interest. So, all my videos I always talk about all this ML algorithms. Please go to Professor Andrew Ng's video if you are interested more about that, or any videos. I recommend couple of papers in the videos for you to read, because that is how you know how this data, all this model is applied in a real data, how people have used it. And for the tools, if it is Pro-M or Vector or Orange or RapidMiner tab, go to YouTube. There are plenty of videos explaining how to apply each and every algorithm, like what data to apply, which buttons to click, everything is there. There is no need for us to teach everything which is already existing. We do not want to reinvent the wheel. So, the idea here is motivate you, there is a tool, this can be used, go and learn it, that is the whole idea. Okay. And this course is trying to pull out what data to collect, what are the learning resources, what are the different environments, and how you can apply it. Pulling these 3 things, the data collection, the environment and the ML together, and how to infer, that is what we are trying to do in this course, not to teach every ML or the tools or algorithms. So, where do you go next? We will talk about that next. Thank you.